multiple network. Pay attention, we have discussed the equal set of the two-pole network, but we assume it's passive. This passive means there's no independent source inside. No independent source inside. No inside. If there's independent source inside, we will discuss active mode. That means there's independent source inside. And we will discuss star and net connection. What does this mean? This means this is Y to data connection. Y to data. But if we have one more branch, just then there will be net connection. And at last, we will discuss the indefinite admittance matrix, IAM. And this will be the emphasis of this chapter. At first, we discuss a network solution exists or not, the condition. Any actual network will have a solution, and only one solution at one time. At any instant, at any time, it will have only one solution. But the second model, pay attention, this second model, this actual network, they have difference. May have one solution, or may no solution, or may many solutions. For example, this 10 wall, this 5 wall. So for this circuit, there's no solution. Or for this 1 ampere, this 2 ampere. So this is the second model. They have no solution. Sometimes there will be many solutions. For example, this 10 ohm. So this will be 1 ampere. But for this current and this current, there will be many solutions. If a network have no solution or many solutions, it means the model is not accurate. This model is not accurate. It's not real circuit. For a real circuit, there will be a resistor. So if the resist, there will be only one solution. If the resistor equal to 0, there will be no solution. For a RLCM network, the sufficient condition is if network N comprise only RLCM, this M means mutual inductance. If no loop of independent voltage source or no cut set of independent current source, the network will have only one solution. What loop of independent voltage source? So this loop of voltage source, this will be cut set of current source. If there's no, then there will be only one solution. If there's such loop or such cut set, there will be many solutions. For a linear resistance network, have one solution, the sufficient and necessary condition is assume the network function Tx equal to B. The T is a matrix. The xb are vector, and the x is always a variable. The b always related to the source. When and only when the delta t equal to not equal to 0, delta t, this network will have only one solution. The solution is x equal to t inverse multiple b. So if the delta t not equal to 0, the solution will be only one. Okay, we'll discuss the passive multiport network parameter. We discuss passive at first, and then we discuss active later. We discuss short circuit, it means Y parameter at first. Multiport, port 1, port 2, port 3, and port N. The inside the passive means no voltage source, no independent voltage source, current source. Is a generalized of two-port network Y parameter. We use port voltage as stimulate, as the source, the port current as response or as variable. This is variable, this is source, this source, or this result. I1, I2 to IN, U1, U2 to UN. So for every Y11, Y21, Y2N, YN1, how to found this Y parameter? This Y parameter will be a total N port. That will be N multiple N. N multiple N. How to find this Y parameter? The method is, at first, assume all source is 0 except for K. For example, when we try to calculate the Y11 to YN1, we assume U2 0, UN 0. So all these points should connect. Then we calculate the I1, I2, and IN. And from I1 over the U1 is Y11. I2 over the U1 is Y21. Add U1 only here. And calculate I1, I2 to IN. And then use I1, I2 to IN to divide it by the U1.
Yes.
Okay, because the show my network is not very well. Okay, I will continue. Then we can should connect the U1 again, other U2, and then U1 and UN should connect other U2 a source again to calculate the column 2 and the column N. So for the Y parameter, we calculate column 1 at first, and the column 2, and then column N. We also call this Y parameter as the short circuit parameter. The unit is Siemens. We also call as the admittance parameter. I equal to YSCU. This I is port current I1, I2, IN. This U is port volt U1, U2, UN. Okay, we don't discuss this part. We don't care about this. We don't care about it. Then we discuss the Z parameter, open circuit impedance parameter. It's generalized two-port network Z parameter. We use the port wall current to express the port voltage. Use the Z, I1, I2, IN to express the U. So use them as a current source. For the Z11, for example, we try to calculate. This port 1, this port 2, this port 3, this port 4, I1, I2. At first, we assume the I2, I3, IN is 0. That means it's open. Only other source, I1 here. And then calculate the U1, U2. Calculate the U2, U3, U4, and then U1, U2, U3, U4 to divided by the I1, go to the column 1, and then assume I1 0, I3 0, only I2 left, then calculate the column 2, and then calculate the column n. This is a method to calculate the z parameter. The z parameter is also use the open circuit method. So we also call it as the open circuit impedance parameter. Okay, we don't discuss this part. Hybrid parameter is a generalized two-port network H parameter. Some voltage and some port current are stimulant. Some voltage and some current, other voltage and other current are response. I1, U2. Pay attention, this is I1, U2. This is a vector. This is a vector. This is also vector. This is a vector. This is also vector. So you call this as a H parameter, class 1 hybrid matrix. We can also use a U1, I2 to express I1, U2. We call this as a class 2 hybrid matrix. For the n-port network, reciprocal, this is reciprocal condition. For the Z and the Y, the reciprocal condition is Z equal to ZT, Y equal to YT. When the port number is even, choose half of the port as input, the other half as output. Then we can get the T parameter. For example, the 4-port network. Port 1, port 2, port 3, port 4. Then we use the 3 and 4 as output, 1, 2 as input. So we can get U1, I1, U2, I2 equal to the T parameter U3 minus I3, U4 minus I4. So this is also T parameter. Half of them as output, half of them the left half as input. This is input. This is output. This is output. This is T parameter. So this 4-port network, T parameter. And of course, the T parameter has the type 1 and type 2. Type 1, type 2. The ZOC-YC relation, ZOC-YC and H relation, the ZOC will equal to the YC inverse. We can also calculate the H and the T from the Z and the Y, calculate H and the T. The multi-port network connection. This discusses how to connect the multi-port network. At the first, parallel. This parallel we have discussed in the 2-port network. It uses 2-port as an example. This parallel. So if the 3-port, assume this port 3. So parallel connect. This as a new port, port 3. So this parallel. When parallel connect, the result is the total network Y parameter will be the network 1 and network 2 Y parameter added together. we have discussed in some conditions, parallel connect will violate the port condition. And in the practice, we have a simple method. To judge if the port condition still confirmed. At first, we add a source in the left side and short connect the source of the right side. Short connect. This means all the four terminal short connect. All the four terminal short connect. And then we judge if this current is zero. If this current is zero, that means there's no current and there's no voltage. No current, no voltage. So this current will equal to this current. This current will equal to this current. And then this will equal. Then judge the left side. If this voltage source, this voltage meter, this meter is zero. If this is zero, that means short connect will be no current. So this current will equal to this current. This will equal to this current. So if V equal to zero, the left side confirmed. If the right side, if this voltage V is zero, the right side is confirmed. So we use this method to judge this network parallel connect. The port condition is still confirmed. As example, in this circuit, this V will be zero, because this point connect here, this point connect here also, so it will be zero. So this parallel connect have no problem. Y equal to Y1 plus Y2. But for this circuit, this V not to zero, because this point connect here, but this point connect here. So this V will equal to the voltage source, not to zero. So in this case, this Y not equal to this Y1 plus Y2, not equal. Because in this case, in this parallel, Y1, Y2 not exist anymore. Serial connect. For the N port network, N1, N2, all ports serial connect as this serial connect. And then we use the Z2 express. So the total Z will equal to ZLC1 plus ZLC2. So this will similar to two-port network serial connect. And we have discussed when serial connect, sometimes the port condition will be violated. In the practical, we can use this simple circuit to judge this serial connect. First, we assume this current is zero, so it's open. It's zero, then open. We judge this V. If this V is zero, that means the short connect, the current will be zero also. This I is zero. This I is zero, so this current will equal to this current. This current will equal to this current. So the left side confirmed. And then judge the right side. For example, for this circuit. In this circuit, this V will be zero because the short connect. So they can be serial connected. But in this circuit, this V not equal to zero. Because this V will be this Z voltage. So in this circuit, this Z not equal to Z plus Z2. But in this circuit, the Z1 equal to Z equal to Z1 plus Z2. Hybrid connection. We have not discussed hybrid connection for the two-port network. Assume n-port network NA and B have the same voltage and current port. Current port serial connect. Voltage port parallel connect. And the connect condition will not valid, then we call NA and B as hybrid connect or serial parallel connect. For example, for the two-port network, if we serial connect the left side, but parallel connect the right side, so we call this as a hybrid connection. Just hybrid connection. Some port serial connect, some port parallel connect. This is hybrid. So this is a serial connect, this is parallel connect. When hybrid connect, we use hybrid parameter to express. For the serial connect, for the serial connect, the current will be the same. For the parallel connect, the voltage will be the same. So we just add the hybrid parameter, then it will be okay. Serial connect, this is the same. Parallel connect, this is the same. This is the same. So if the voltage port serial connect, current port parallel connect, we can use the H sharp to express. So this hybrid, when the hybrid connect, we can also use a similar method to judge if the port condition conform. And for the complicated network, we can analyze dynamic and can also decompose to different simple network analyze. For this network, we can treat them as this network parallel with this network or the network. In practical, we can use one transformer to make sure the port condition. What does this mean? For example, in the sinusoidal signal, if we serial connect them together, sometimes the port condition will violate. The port condition will violate. If we try to avoid this, the port condition violation, the method is add a transformer. For example, how to add a transformer? Add a transformer here, and then here. Then serial connect the transformer. Just one, and add a transformer here. serial connect transformer. So this is serial connect by transformer. So in this circuit, the port condition will be conform. And this Z will equal to Z1 plus Z2. Why? Because for the transformer, this current will equal to this current. This current will equal to this current. This will be equal. This will be equal also. So the N1, N2 still two-port network. The serial connect will never violate the port condition. The physical efficiency is because the transformer isolates the N1 and N2. They have no any electrical connection for this part and this part. They have no electrical connection, but only magnetic connection. The essence is no electrical connection, but magnetic connection. So this is essence. So in practical, we can use a transformer to make sure the AC circuit conform to the port condition. So this is connect in the practical. We need to introduce another connection. Cascade connection of multi-port. For the 4-port network, connect them together. So this cascade, and then the total T equal to T1 multiple T2, this cascade. So for the connection of multiple network, we have introduced four kinds. First, parallel. The second, parallel use Y2 express Y1 plus Y2. The second is serial. Use Z2 express plus Z2. And the third is a hybrid connect. Use H2 express. And then the cascade. Use T to express T1 multiple T2. This is multiple T2. So we have total 4 kinds of connection for the multi-port network, also for the 2-port network. And then for this part, we have discussed the YSC, GOC, and the T parameter, the H parameter of the multi-port network. Multi-port network. So you should know how to calculate the YZTH. And the next time we will discuss active multi-port. This for the next time. Okay, today class is over. If any question, you can ask here. Do you have any question? If no question, I will close the meeting. Share PPT. Okay, I will share PPT soon later.
Okay, thank you. Bye bye.
Okay, see you. You're welcome.